Professor R. Ashokamani, Director, Research and Development, Dhanalakshmi College of Engineering, Tam from Chennai. He is former professor and head of the department, Physics, Anna University, Chennai. He is presently guiding 3 research scholars. He has more than 44 years of UG and PG teaching experience and 33 years of research experience. 14 research scholars have obtained doctorate under his guidance in the area of material science and solid-state physics. He has more than 150 research publications to his credit, of which 90 are in international journals. He has authored a book on solid-state physics, which is an international publication. He has participated in several international conferences, both in India as well as in foreign countries such as USA, UK, France, Germany, Italy, and Yugoslavia. He has been a guest scientist at ICTP, Italy, several times. He is a fellow and treasurer of Tamil Nadu Academy of Sciences.
Welcome to the UGC lecture series for the BSc Physics Honors students. We were seeing so far the geometrical optics. Now we will pass on to wave optics. This is lecture number 11. The contents of this lecture will be based on the theories of light. You asked a question, I got a lot of tube lights here. The question that we are asking is, how does the light reach my eyes? How the vision, how the light is coming to the eyes? Is it coming in the form of rays or waves or particles? That is the question before us. And so now we will go through the theories of light. So the contents or theories of light, the salient features with regard to various theories. And when we talk about light, it was told by Albert Einstein, for the rest of my life I will reflect on what light is. So light is a wonderful subject in the sense that the vision and how does light get propagated from the source to the eye of the observer. And you have got the sunlight here, and the sunlight takes more than 8 minutes to reach the earth. From the sun, the light rays are coming from the sun, and it takes more than 8 minutes to reach the surface of the earth. And in what form does it come? Does it consist of rays, or is it made up of waves or particles? Whether the light is coming from a bulb or from the light coming from the sun, how does light propagate? Now, time taken for light to reach the earth from the sun, it is 8 minutes and 19 seconds. And so you got sun rays, 8 minutes and 19 seconds. I am using the word rays, but the question is whether they are rays of light or you have got waves and so on. The theories of light are as follows. The first theory which was propounded was the corpuscular theory of light. Then comes the wave theory, followed by that you have got electromagnetic theory, and finally the quantum theory of radiation or quantum theory of light. Now, how do you get the corpuscular theory? The famous scientist Isaac Newton, who lived from 1643 to 1727, he proposed that light should be traveling in the form of rays, ray optics. Then the light beam is made up of packets of energy, or he gave the name corpuscles. So the name corpuscular theory of light. So the light that is coming from a source, it is coming towards the observer. So the light is made up of corpuscles or packets of energies, and it travels in the form of straight line. Light travels in the form of a straight line, and light is made up of corpuscles. When these particles hit the human eye, energy is produced. This results in vision. The corpuscular theory, it is believed to work very well, but you have what is called a wave theory of light proposed by Christian Huygens, and according to the wave theory which was proposed by Huygens, a luminous body is a source of disturbance in a hypothetical medium called ether. The point is, Newton did not require any medium. You know, you have a water wave. In the case of water wave, water is the medium. And now you know about sound waves. Now in this room, if there is no air at all, you are sitting there. If there is no air, if the room is completely evacuated, then you will see my movement of my lips, the sound will not come. For a sound to be propagated in a room or any place, you require the medium. What is the medium? The medium is air. So air is required for sound to be propagated from one place to another place, or sound to reach from the person who is talking to the other person who is listening, if at all he is listening. So it requires medium. Similarly, you have a mechanical wave, water wave. The wave is produced in water, but according to the corpuscular theory which was proposed by Isaac Newton, it requires no medium at all. But the wave theory which was proposed by Huygens, it requires a medium, and the medium he gave the name ether. Irrespective of the fact whether you have got a star or the sun, whether you have got air or vacuum, whatever in the interstellar space, irrespective of whether you have got air or any other thing, it is called all-pervading ether. Everywhere in the universe, ether is present, and so he assumed the presence of what is called ether. There is a medium required for the light radiation to come from the source to the observer, and the light travels in the form of waves. So according to wave theory, light travels in the form of waves. In water, when you drop a stone, a wave is propagated on the surface of water. Similarly, the ether is the medium which is responsible for the propagation of the light wave that is emanating from one point to another point. The distance from the source is propagated in the form of waves through space, and energy is distributed equally in all directions. And so when you got a disturbance, the energy is distributed in all directions, and the source is emitting waves. And so the light is traveling in the form of waves, and it requires a medium. The ether is the all-pervading. All-pervading means it exists everywhere in the universe. So the wave theory proposed by Huygens requires a medium, whereas the corpuscular theory does not require any medium. Then came James Clerk Maxwell. He proposed what is called the electromagnetic theory from the mathematical equations, because prior to Maxwell, the relation between electricity and magnetism was established, and that made Maxwell to think. And so Maxwell ingeniously combined electricity and magnetism and developed equations which showed that light is made up of electromagnetic waves. So Maxwell showed that light waves are nothing but electromagnetic waves. You have got electric vector and magnetic vectors mutually perpendicular to each other. So the light is made up of electromagnetic waves. Then came what is called the quantum theory of radiation or quantum theory of light. Certain experiments demanded that making light to travel in the form of waves, or assuming light to travel in the form of waves, is inadequate to explain certain phenomena, certain experimental observations. So certain experimental observations necessitated the formation of so-called quantum theory, and it was proposed in 1901 by Max Planck. So quantum theory was proposed by Max Planck. The energy in any light source or a black body or any light source which is emitting radiation, the radiation is made up of packets of energies again, but they are called quanta. So, the quantum theory, which is proposed by Max Planck, it led to what is called quantum mechanics. But it's a different story, but the quantum theory says light that is coming from a source consists of quanta of radiation, and each quanta is given the name photon. So, you talk of photonics. So, light is made up of photons, and it was Einstein who was able to explain the phenomenon of photoelectricity, for which he was given the Nobel Prize. He explained the phenomenon of photoelectricity based on the quantum theory of radiation. So, there are experiments like the photoelectric effect, which demands, so the experiments, some of the experiments demand that light should be considered as though it is made up of photons. So, the quantum theory is required to explain certain set of phenomena. One of them is the so-called, the photoelectric effect, and you have got Raman effect, Compton effect, and so on. These experimental observations or these effects can be explained only using the quantum theory of light, which was proposed by Max Planck. Then again, we will go to the corpuscular theory, and we will see make an in-depth study of various theories and the shortcomings of the theories in order to have a better understanding of why a particular theory is abandoned. Why do you go from one theory to another theory? What are the advantages, disadvantages, demerits, and why should you drop one of the theories? So, here comes again the corpuscular theory. Newton proposed particles of light, the particle theory of light or corpuscular theory of light, to explain the characteristics of light. So, one of the most famous books, Optics, published by Isaac Newton as early as 1704, according to him, I think light is a stream of tiny particles called corpuscles. This is a very nice original work of Sir Isaac Newton, who is considered to be the topmost physicist of the humans. So, Optics, a treatise of the reflections, refractions, inflections and colors of light by Sir Isaac Newton, knighted. So, he lived, as I told you, between 1643 and 1727, and the corpuscular theory says light travels in straight lines. And so, you got light traveling in straight lines, and it comes from there to the particles are coming here. And the important point is, it comes through the slit. You consider the opening here, right? From the slit, it comes here and falls on the screen. So, let us go back. You have the light, right? So, the light, the dots refer to the quanta, the particles of energies. Then light travels in straight line. So, it comes from there to this place, and then it comes through an opening or slit, and then it is incident on the screen. You got the particles on the screen. The point I want to tell you is, light does not bend into the shadow, or when you got an obstacle or an opening, light does not bend around the obstacles. That is what you understand from the corpuscular theory of light. Now, corpuscular theory of light says light travels in the form of straight lines. Therefore, if you have got an object here, so you have got a source here, object here, there is a screen, you get a shadow, right? I will show that a bit later. You get a shadow, and the formation of shadows can be understood. It is an acceptable thing, that is, accepting light to travel in the form of straight lines. We will be able to explain the formation of shadows, that I will be showing a bit later. And so, the corpuscular theory is quite capable of explaining the laws of reflection and other phenomena, and at this point we will have a break. Welcome back to the break. I have been telling you about the corpuscular theory of light, which was proposed by Isaac Newton, according to whom light is traveling in the form of in a straight line, and the law of reflection, one of the laws which states that when light ray is incident on a mirror, it is getting reflected, and the angle of incidence is measured to be equal to angle of reflection. That have been done by experimenters, earlier experimenters. The angle of incidence is equal to angle of reflection. That you are able to explain on the basis of Newton's corpuscular theory, and so the corpuscular theory is correct because you are able to explain one of the laws of reflection. Similarly, you have the laws of refraction that says n1 into sin theta 1 is equal to n2 into sin theta 2. In the picture that I am showing here, you can observe and understand what are theta 1 and theta 2. When a light ray is going from one medium such as air into water or glass, the second medium is a medium of a higher refractive index. This may be air and this may be glass or water. So, when light ray is incident and on the interface between the two media, it gets refracted and it bends towards the normal if the refractive index of the second medium is higher compared to the first medium. So, it is getting refracted. These are the angles theta 1 and theta 2. They are the refractive indices of the two media, n1 and n2. Okay, this is theta 1 and theta 2. Now, what I am trying to tell you is n1 into sin theta 1 is equal to n2 into sin theta 2. This law has also been experimentally observed, and it was given by Willibrord Snell. He discovered it in 1621. So, the refractive index of the material first medium multiplied by sin theta 1 is equal to n2 into sin theta 2. This relationship, all of you know, it is known as Snell's law of refraction. So, this law of refraction also can be explained on the basis of the corpuscular theory of light. So, you have the corpuscular theory of light, which is able to explain the laws of reflection, laws of refraction. Now comes the formation of shadows or even eclipses. You have got a solar eclipse, lunar eclipse and so on, and you have got two objects here. You have got object here, object here. You place a ball in the path of the light beam. You have got light is coming from this source. The light will be going this direction, and again it will go in this direction because it is obstructed by a ball. You have got a source is here, you have a ball, then the light ray will be going in this direction. Another light ray will be going, because light cannot go through the the medium, the obstructing medium, and so you get no light gets through here, right. So, it gives rise to the darkness. You have got a shadow here, there is a shadow region, and so the shadow cast by the ball can be seen here. And similarly, when you have got a source here, the light ray will go in this direction and another light ray will go in this direction, leading to the formation of shadow of the ball. So, the point is only the light from the top of the source gets through here. So, from this region, okay, the point is the formation of shadows again can be easily be explained on the basis of the corpuscular theory or the ray concept. Light travels in the form of rays. So, light is traveling in the form of rays. The concept of rays or the rectilinear propagation of light. What is rectilinear? Linear means light travels in the form of a line, right, the form of rays. Light does not bend at the edges of the obstacle. This is very important. According to corpuscular theory of light, light does not bend around the edges of the obstacles. Therefore, the casting of shadows or the formation of shadows can be explained on the basis of the corpuscular theory of light. At this point of time, because of the eminence of Sir Isaac Newton, people thought definitely light should be traveling in the form of rays. But however, there are certain other experiments which made people to feel that light may be traveling in the form of waves. So, one of the persons who strongly felt that light should be traveling in the form of waves. It is Christian Huygens who said that light travels in the form of waves. So, in the 17th century, two scientists had different views. It is important to note they are contemporaries. They were working, they lived during the same time, and because of the preeminence of Sir Isaac Newton, the Christian Huygens ideas were not very much welcome. There were a lot of opposition. In spite of the opposition, Huygens strongly believed that light should be traveling in the form of waves, and the wave theory proposed by Huygens, it is able to explain the laws of reflection, refraction and other phenomena as well. But according to Huygens, he believed that the light waves are longitudinal waves. This point I want to emphasize. Light travels in the form of waves, and they are longitudinal waves. As I told you earlier, the light wave can be propagating, will propagate from the source to some other region. The propagation will take place through a medium. It requires a medium. The ether medium should be there, right? So, light is particles, that is according to Isaac Newton. But he says no, light is waves. Light consists of waves. That is what Huygens proposed. So, there is a conflict of opinion with regard to light. There are two opposing views. Light consists of rays, or light is made of rays. You have got a light beam, it is made up of rays. The same light beam, according to Huygens, it is made up of waves. So, who is correct? Now, therefore, you have the Huygens theory. Let us spend some time on the Huygens wave theory. In 1678, Huygens proposed that every point of a source, you have got a source here, got a source, it may be extended source, it is emitting radiation. So, every point will emit radiation in the form of wave, and you will be having what is called a spherical wavefront. You have got a spherical wavefront, and so the energy is dissipated, and all the particles, what is that medium? Medium is ether medium, right? So, the ether medium is responsible for the propagation of light wave, and so now the light wave has come up to this region, right? This is called a primary wavefront. A spherical wave has come up to this point, up to this distance. Then every point in the ether medium which is affected by the energy possessed by the spherical wave, then every point will act as a secondary source, which in turn will emit what are called secondary wavelets, and the envelope of the secondary wavelets will give you the next wavefront. You have got a wavefront, and the next wavefront, how do you obtain? As I will be showing in the picture to come, the secondary wavelets are nothing but the envelope of the secondary wavelets will give rise to the advancing wave. So, the advancing wave is nothing but every advancing wave is obtained from the envelope of the secondary wavelets, which are emitted by the wave which is advanced there bit earlier. So, I will be showing now in the picture, this is a source, the common center of both the wavefronts. You have got a wavefront here, another wavefront here. So, the light radiation coming from here, it is a source of disturbance, and it has moved up to the region WW. WW is the spherical wave, WW. The spherical wavefront, each point that you have got here, it emits a wavelet. You have got a wavelet here, a wavelet from it is A, B, C, D. These points which are affected, they are the points in the ether medium. They are affected by the wavefront that you have got here. The spherical wavefront affects the particles, the ether particles here. These ether particles which are affected, they act as secondary sources, and they emit in turn what are called secondary wavelets. They are the secondary wavelets. You take the envelope of all the secondary wavelets, right? Envelope of wavelets will give you the advanced wave. So, from this wave has advanced to here, then from this point again you will be having secondary wavelets, right? From here, the points A, B, C, capital A, B, C, D, they act as secondary sources again, and then you can construct another envelope and so on. That is how you get the advancement of the spherical waves. Similarly, you have a plane wavefront. The plane wavefront, each point emits wavelet. So, the plane wavefront ABCDE, small ABCDE, it advances to capital ABCDE. The plane wavefront, it gets propagated. Either the plane wavefront or the spherical wavefront, the advancement of the wavefronts are due to the fact that the ether particles which are disturbed, they act as secondary sources and they in turn emit secondary wavelets, and the envelope of the secondary wavelets will give the advancing wavefront. The envelope, right, that gives the advancing wavefront. Similarly, the envelope gives the advancing wavefront. That is how the wavefronts advance in the case of the spherical wave or the plane wave according to Christian Huygens, where the particles which are affected, the particles of what? The ether particles are affected, and how the wavefront advances. So, I will show you again now what is R. You can look at the diagram which I showed earlier. R is nothing but the distance through which the spherical wavefront has advanced. If c is the velocity of light and t the time taken for the disturbance to go from P to the point small e, small r will be c times t, because c is the velocity of light, t is the time taken. Therefore, obviously r will be equal to ct, right. This is what I am showing here. At time t, it has got a radius r. So, from the point source, the spherical wavefront would have gone through what distance? Through ct. R is equal to ct. So, you can draw a spherical wave, or you can draw a circle, and this r will be, the radius of the circle will be equal to ct, or the radius of the sphere will be equal to ct, right. So, these secondary wavelets interfere to form the new wavefront w prime at t prime, that is showing w prime. There is the advancing wavefront, right. This is the original wavefront, the primary wavefront, and the secondary wavefront, and again the secondary wavefront, and so on. That is how the wave is getting propagated according to Huygens. So, the Huygens theory was able to explain the laws of reflection, refraction using this principle, using what I showed you now, the propagation of light waves in the form of the primary wavefront giving rise to advancing wavefront and so on. But he could not explain the deviation from the rectilinear propagation that occurs when light encounters edges. Now, what I will show you in the lectures to come, when light is passing through the edges of an obstacle, there will be bending of the light beam, and that will be called as diffraction. The bending of the light beam will be called diffraction, and the phenomenon like diffraction could not be explained by Huygens theory. And not only that, you have the phenomenon like polarization, which was observed by Huygens himself. Huygens observed, the double refraction, which he was able to explain. So, he was able to explain the laws of reflection, refraction, and also double refraction using wave theory. But he could not explain the phenomenon of polarization. That is the failure of the Huygens wave theory. And again, the problem is Huygens could not explain what will happen to the waves which will be traveling in the backward direction. You have got the point source here. He was talking about the advanced wavefront in the forward direction. Now, what will happen in the backward direction, in this direction? So, he is not able to explain the propagation wave in the reverse or backward direction. Now, these are the problems that one encounters when you talk about Huygens theory. So far, we have seen the outline of Huygens theory. Let me now summarize as to what we have seen in today's lecture. We have seen the various theories of light, the Newton's corpuscular theory, the Huygens theory, the Maxwell and the Max Planck's theory, and some other salient features. Now, the questions are: number one, how much time does light take to reach from the sun to the earth? What is meant by a secondary wave? Was Huygens able to explain polarization? If not, what is the reason? With this, we come to the end of the first lecture on wave optics. We will do the rest of the things in the lectures to come. Thank you.